Good morning, everyone. Let me change my glasses so I'll be able to see my note clear, but the fuzzy eye comes off me. Again, to all the young friends and also younger friends in this room, and when you get some certain age, don't want to talk about old things. But it's my great pleasure to be here to meet you again. And this is my first overseas trip after the COVID-19. So I sort of get scary because facing the crowd is always the problem when you just come from blackout. So forgive me if I get my speech just stumbles and won't be able to continue. But first of all, I would like to thank Peter for the introduction and bring a very good memory of between he and me. And he's now very, very well established and also well-known coral reef ecology and also restoration in not only in this region but also to all over the world. And I also want to thank Dan Wei and the local, the Auckland community for the invitation. This is my really great honor to be here to share my work on coral reef. Particularly, I want to share my recent adventures. It's really an adventure to me in the so-called long-term social ecological research teaser platform. This is the logo I'm on. So I need to wear this T-shirt when I give a talk, so I can need to convince the funding agency from my government to continue to fund this long-term work. Okay, so you must say the good word for me, please. Okay, so before I start my talk, I would like to apologize to those who know me for a long time. Also want to come in to hear my talk, my research on the coral evolution and the genetics. And but I don't want to say this is the fake news. But this is the something I want to say to those friends that today I'm not going to spend the time on this, and I do have a reason. Okay, the reason is I did study coral evolution and the genetics through my career, and I was very lucky to be the first generation to catch up with the PCR techniques. And as the first generation of coral scientists using this technique to explore the coral evolution history, and with help from my JCU supervisor, Professor W. Miller, he also in this room, to start this journey. So you can see that from my first paper published in 1995, I used the 2025 page pay, I can finish my PhD. Okay. But with the advance of the technology, we actually nurtured the second generations of the coral reef evolutions. Dr. Mei-Fan Lin, and he also in this room, and then he used the 291 single copy gene from whole genome to complete the story I was start to address in my PhD, is how coral evolved. And is finally we close the whole story by proving that coral is the only organism in the sea can help to build up such a large biological entity in the ocean. So we have to protect it because we have no second chance to lose it. And with the advance of the genome technology, I believe there's a more qualified young registrar in this room, like Dan Wei, like Peters, and so on, all give a very important talk and to handle this topic better than me. So I decided to move on. Okay, so today I don't think I need to convince all the people in this room that how important a healthy reef is important to our society. So I will go straight to one slide to show you that the challenges of the coral reef we are facing today. And then I will give you some of the work I was involved in the global conservation effort a couple of years ago. It's not a new story, but I think it's important to bring again to save the coral reef. Then I will use the local and regional effort using the long-term ecological research in Taiwan, also in the East Asian region, to show that with this kind of data, we'll be able to advise local and regional conservation to the region. Then I will move on to the so-called the challenges, which is, I want to convince you that we probably need to move faster to incorporate the other side of the science into this kind of long-term ecological researches. And that's the adventure I will get into the so-called long-term socio-ecological research, LTSA, using the case study I have from Taiwan. So in 2018, IPCC 1.5 special report suggests that if we can control the mean temperature below the 1.5 degree, there will be about 10 to 30% of global coral reef. So we'll be able to spend our effort trying to save it. However, the newest model study published last year suggests that even at 1.5 degree, 99% of global coral reef will be disappeared due to the frequent heat waves. Nevertheless, from the reef conservation perspective, it is still important to identify potential reef that can survive rising seawater temperatures and prioritize conservation. And hopefully they will be served as the sea bank for the restoration after the sea surface temperature stabilize toward the end of this century. So the question is how to identify the potential reef for prioritizing conservation. Is it reef? Is the community in this hand, or the tropical reef which is experienced the serious bleaching in recent years in the other hand? So several years ago, this is not new. Several years ago, I had opportunity to get involved with this global exercise called 50 Reef Project. I believe most of you are familiar with this project, and through its publication, also through the documentary called Chasing Coral. And I think it gave people a lot of awareness through this global exercise. The idea of the 50 Reef Project was to evaluate the several global database that are related to the impact of climate change and also connectivity. So, and that we include 5 metrics, including 3 related to the temperature effect, and 1 of the physical disturbance, and 1 for connectivity. Using the master so-called modern portfolio series, we are able to identify the global portfolio of the coral reef with a good chance for both surviving the impact of climate change and help to repopulate the neighboring groups in the future. So this is the result of the 50 plus sub-regions identified by this project. So in the last 5 years, and I also believe that the plenary talk delivered by Rennie and yesterday morning also benefit from this part of research, that with the funding of $86 million, the project reached implementation organization, 8 funders conducting projects over 60 reefs across the 14 countries. The impact of the 50 Reefs project are highlighted in advancing reef policy, NPA design, improving the water quality regulation, and reduce the pollution. But the question is, how about those reefs outside the 50 plus reef? Can we be able to using another criterion to select reef for local and regional conservation? And this is one of major questions left in the several workshops from the 50 Reef project. So in the next few slides, I'm going to using the data like biogeographics, biodiversity, and also biogeophysical setting to demonstrate that with this kind of data integration, we'll be able to assist the advice for the local and the regional conservation. So in my second part of my talk, I will continue to give you the example using the Taiwan and also the East Asian region data for this purpose. Kenting Coral Reef, located in the southern tip of Taiwan. It's over here. It's not really clear. It's the largest fringing reef in Taiwan. In 1984, the very first national park was established in Kenting. And interesting, in the same year, the third nuclear power plant was also constructed and becoming the only nuclear power plant in the world sit on the reef. So I'm very lucky I own this, not own, but I have this reef to accompany with me for the 30 years of my research. So there are some ecological data has been collected since the 1980s. And there's once the National Science Councilors, the major funding for research in Taiwan, won't establish the LTER, but they actually terminate only for the one phase. Although the national park continue to support the research, the long-term ecological research, but the funding is only enough to conduct the defensive survey. However, during the course, we are managing to collect the information of the sea surface temperatures, the typhoon, and human disturbance data, including the coral bleaching event throughout the time. One of the unique features environmental siting in Kenting Reef is the tide-induced upwelling in the bay. The figures show you the data local deposits in the modern site in Kenting National Park. You can see there are the significant indication of the consistent temperature drop through the time, and this is because the tide bring the water from 100 meter depth within the bay around here. So the cool water helped to reduce the temperatures in the outlet or nuclear power plant. Sometimes they can create a temperature variation up to 6 to 7 degrees Fahrenheit. We then calculate the nearly 400 typhoon routes in the last 100 years, and it showed that the over 57% of the typhoon actually directly impacts on Kenting Coral Reef during the time. So this is the figures show you the overall mean coral cover, total algae cover, and the macro algae cover in the green bar. From the available data, you can trace back to 1987. So throughout the time, the Kenting Reef still dominated by reef-feeding coral before the typhoon Borak hit the reef in 2009. It took about 7 years. Took 7 years for the coral cover to return to about the 40%. Nearly in the early 2016, before a back-to-back two typhoon and one the bleaching event hit in the summer in the 2016. And 4 years later, the coral cover returning to 40%, and interestingly, the macroalgae did not rise as the previous period between 2009 and 2016. And we also observed from our permanent model site the coral species and also the so-called functional group changing through the time. And from the socio-economical analysis, we also see that overfish and the impact of the tourists in our long-term monitoring site. As indicated in the previous slide, that the temperature sightings are definitely different in the peninsula site, also within the bay. And the coral cover also show a spatial and also temporal variation in the different subregions within, with the one in the west part of the bay, showing that the coral cover is also maintained very high through the time, and the macroalgae did not actually pick up, become dominant through our monitoring in the last 30 years. So this slide show you that in our monitoring side, the images showing that the major changes of the coral community through the time. Some of the monitoring reef are really desperate during certain years because the Taiwan case is off the crash. But in a decade, the coral start to run back. So using the environmental setting and also biological and also the ecological data, we developed the ecological resilience index, and this gives the advice to the local the national park for the further conservation enforcement for the Canadian coral reef. We also move on to analyze the Taiwan-wide long-term ecological data using the reef check data between 1997 and 2017. The pattern showing that generally the coral cover is quite stable at the 33% through the whole entire Taiwan. And okay, the data we got from Taiwan also contribute to the regional trend and analyze. The exercise to analyze the long-term trend and status of the coral reef in East Asian region start in 2016, and we went through several workshops. But due to the COVID-19 lockdown, the effort was not complete until last year. So the major report come out to show that the reef is not as desperate as we expect. And with effort from the Professor Chop Min and Dan Wei, and he's the former president, now he's the Dr. Sammy Chand in AMS, Australia. We'll be able to turn the meta-analysis into the scientific publication. And this paper just come out last week. Over 24,000 reef was surveyed, performed under 37 years, and nearly 2,000 sites was surveyed through the whole entire region. And the results show that overall, the coral cover at the survey site had not declined, and macroalgae cover had not increased, and there's no indication of the phase shift from the coral to macroalgae dominance on the reef. And from the socio-economic analysis, there's a negative association of a coral cover with the coastal urbanization and the sea surface temperatures. The conclusion from this paper also call for improving the monitoring method and also enhance the regional cooperation. This region milestone publication cannot be achieved by strong 3C. It's not iPhone, iPad, and iMac. It is the coordination, cooperation, and collaboration that Professor Chop Min already indicated that in his plenary talk at the very first APCI's meeting in 2006 in Hong Kong. And other important drive in the regions is several characters, including Professor Ampus that initiated and also organized the very first APCIS in Hong Kong back to 2006. The photo here is not much clear, but I want to show you that those young face in this photo open from this initiation, cooperation, and actually indeed some of them are now already well established and continue to conduct the region cooperation. So to conclude the first and the second part of my talk, the global effort such as the 50 Reef Project provide a science-based framework to prioritize and increasing the global investment in coral reef conservation. And the long-term ecological research on the coral reef would actually help identify reef for local conservation priorities. And regional effort that through the long-term cooperation of GCIMN and APCS coordination show that the overall coral cover in East Asian regions cannot decline, but we also call for the improving the monitoring method and enhance the long-term regional cooperation. So in the paper, although the communication biology paper delivers some positive news that the East Asian coral reef are not as desperate as we see from our region, such as Caribbean, but our data actually encompass the reef from 10 degrees south to over 30 degrees north. That's the diverse reef assemblage in the region might have actually mitigated the coral decline. And this region also encompasses high diversity of social, economy, and cultural characteristics. For example, that the urban reef in Singapore, Hong Kong, and Taiwan, and also the fish impact reef such as Indonesia and Philippines. That might also diversify the uncertainty of this reef under the impact of climate changes. So I'm going to show you, although we are mid-year after the COVID-19 lockdown, but we should not forget that instead of our impact our human being, but our surrounding, particularly coral reef, also have a strong impact by this unexpected event. So this I show you I call the unexpected explosive domestic tour in the islands of Taiwan during the COVID-19 border lockdowns. So the overloaded tourists cause huge socio-ecological impact to the reef surrounding this island. And we are keep monitoring the status and also the outcome for the reef. So in the last part of my talk, I would like to navigate you to my recent research on long-term social ecological research called LTSA platform. I want to convince you that we need to move faster to transform the coral reef governance in order to deal with the rapid climate changes. While entering the era of anthropogenics, the ecosystem ecologists are no longer deal with the simple factors that drive reef dynamics. On the contrary, these nature biophysical factors under the climate changes intertwined with human-derived drivers such as carbon dioxide emissions, trade, financials, and human migration, and especially for the urbanization. So all the factors joined together will significantly jeopardize the future of coral reef. So just one day in this APCIS, we already heard and we will continue to hear in the next 3 days and enjoy the numerous scientific talk and ethics report on how to assist the coral reef to survive the future. But at the end of the day, we should always challenge ourselves and ask the question that, are we doing fast enough to catch up the threats of climate changes? And this is a perspective paper. You may not agree, and may agree with this paper published by Morrison and her colleague in 2020. And this is kind of a wake-up call to me. I hope it to convince you that although we're all doing our job to help coral reef, but we might not be doing fast enough to move from no change to decision points and take the quick action to the step changes, particularly truly face the so-called placebo policy and try to escape the governance trap. So in next two slides, I'm going to show you two examples of what's so-called the placebo policy. Beach cleaning or ocean cleaning definitely raised the public awareness of ocean reef crisis and encourage the people to join the activity. And they will feel they are doing good to help reef, oceans, and our planet. But beach or ocean cleaning should be the final solution for the environmental protection. To really solve the problem, we should actually go up to higher level of policy to do such as source control or plastic reductions. Actions such as the changing the gear to prevent the ghost net or modify the subside policy to regulate the plastic production through operations or gear use of the fishing boat. Otherwise, the beach clean is just another enter the cycle of another beach clean. The second example of the placebo policy actually raised in Morrison's paper is coral restoration. I know coral restoration is quite an overwhelming research and lots of the funding flood into this topic right now. And Nanini actually gave a pregnant talk yesterday and an overview restoration work in Thailand in her plenary. And there are lots of presentation and the poster are all related to these issues in this meeting. But in Taiwan, I have actually observed some different phenomena. The slide here shows you the coral plantations. It's become one of the most popular underwater activity in Taiwan. So this image show you the diver instructors guide the diver how to install the coral napping into the nursery platform in 1992. But the other image I show you here is the bleached coral napping in 2020 and caused by the heat wave near the PMBC, a research facility close to this nursery platform. So another, I would say, provocative or another positive paper just released just a few days ago by Terry Hughes and his colleague. They reviewed 322 studies and a report and showed that coral rehabilitations can be success for very, very small area, typically less than 1 kilometer square of high economical value sites, such as tourist site. They also put forward the message that coral restorations is likely to continue to fail until climate changes and other anthropogenic impacts are urgently reduced. This is another image I'll show you here, a bridge aquapora on the rope in Panmu during the 2020 heat wave. So, to move away from the placebo policy and try to escape the government trap and also speed up the transformations, incorporating social components into the ecological research dimension become very crucial. Here I introduce the platform called Long-Term Social Ecological Research, LTSA. The idea of the LTSA is also on the LTER basis to build up another two annex One, including the transdisciplinary research between nature and the social science to build up the social ecological profiling. On the other hand, to involve regional and local stakeholders to co-design, co-produce, and co-deliver feedback to the research through the coordination. So to achieve this, I choose an island called Green Island, also known as Ridao in Mandarin. It's a volcanic island in the southern coast of the Taiwan and the Pacific side. They are well-developed fringing tropical reef that can extend to 7 meters in depth. We already set up a long-term ecological monitoring site since 2017, so we already have some baseline data as shown in these figures of the coral community around the Green Island. In the socio-economic aspect, Green Island has transferred from the coastal fishery to the tourism-based economy since the 1990s. And currently there's about 4,000 residents in Green Island, but they receive nearly 100 times of tourists per year. And as I just described, the social economy situation in Green Island also experienced the explosive tourists during the COVID-19 lockdown. So this is kind of I would say, ideal model size for us to test the ideas of the LTC. So in this platform, we conduct the 4 parts of the data collection, including geophysical data, the very classical data we all know in investment, and as well as the biodiversity and the ecology research. And more important, we include in the social sciences and also important aspect of the data manager in this whole team. But due to the time limit, I won't be able to give you the detail into all 11 sub-projects, but I'll just highlight some of them here. So one of the projects is to apply the reef soundscape to monitor the diversity in different parts of reef and under the different human disturbances. And my colleague will be able to using the techniques to analyze, to separate the biological sound and compare to the natural sound and also some machine noise come from the boat. We are not only collecting data from the sea, but we also emphasize on the terrestrial study by setting up similar technology on the coral reef, on the Green Island. And to measure disturbances from the human disturbance, one of my colleagues, she is focusing on the water quality monitoring and establish the coral health index under different extent of the human activity. In the social part of the research, we will conduct the qualitative content analysis and in-depth interview with local stakeholders, and this data shall play an important role in feedback to the solution-based implementation to the LTSA. And at the same time, we are planning to promote the installation of the renewable energy, such as the geothermal, which is very rich in the Green Island. Also the solar panel and windmill, try to lead the society into the self-sustained electricity supply for the small islands such as the Rita. And come to the very important point that all the data collection have to be open sharing of research data, not only to the scientific community, but to any stakeholder who actually care about the sustainability development for this small island. So all the data have to be fit into the requirement called FAIR. It's findable, accessible, interpretable, and also reusable. So that is one of the key issues that for LTSA in Taiwan. So this is the conceptual diagram to show how data will be collected and also archived. After data will collect, will be standardized and also conduct the data cleaning. And we have the data platform also in Academia called repository. Is the data repository site for the management and also citation and also the searches. And to reach the stakeholder, we need to have the visualized website design for data portal, including all the information. We also will import the government database, which is scattered in somewhere in the cloud, into our data platform. Okay, and through the authorization and the use of the term, and also the sensitivity data, the scope of policy, this data will be open again to the scientists, and also those stakeholders, including the NGO, really care about the sustainable development of the small island, such as the Green Island. All the data and also all the LTSA data, we also link to the global database like GBIF or GCOM, that through the node we call TIBIF, the Taiwan Biodiversity Informative node, through this channel. So again, we'll come back to this slide. Through the effort of the efforts of the LTSA data platform, we expect to build up the paradigm, the coral reef governance paradigm in Taiwan, which I hope we can move forward and escape the governance trap, and more importantly, to accelerate the transformation for the future sustainable development in Green Island. To conclude my talk, I would like to echo Professor Cho's talk back to 2016. We should continue to enhance the regional cooperations, promote the transdisciplinary research between the social and the natural sciences. And most importantly, this data have to be open data and share with all the stakeholders and the people who are interested in this in the regions. And all the exercise will be able to provide the solution-based approach, and hopefully we will meet the SDG goals. And the most important thing is to assess the transformation of coral reef governance. So I would like to acknowledge all my lab members in the last nearly 30 years who's worked with me, but not all in this photo. Thanks all of them for the contribution and help to accompany me to go through my research. I also want to give the big thanks to the big family here, the GCI member, and also the APCS in the East and Southeast Asian region. And I also want to thank the APCS Oakland Committee for Singapore team and for the invitation. Thank you so much.